Hey everyone, thanks for joining. My name is Lee. I'm a developer on the IBM FHIR Server. Today we're talking a little bit about testing. So, uh, traditional testing pyramid, the theory goes that unit tests are the fastest to run, the cheapest to write, so you should have the broadest coverage there, but you still want coverage at all the layers above it, as shown. When working with a interoperability specification like HL7 FHIR, one of the advantages is there's a set of community test tools already available at the API level tests. So we have Aegis Touchstone. So this is a commercial tool that is capable of executing FHIR test scripts. They're a longtime supporter of FHIR Connectathons, and we've been using this for the last year on the IBM FHIR Server team, and we're generally happy with it, although I think the search test coverage is a bit spotty. The Inferno test tool is an open source test tool that's sponsored by the Health and Human Services Office of the National Coordinator. They have a lot of folks here at the event this week, and so I'm sure you'll learn a lot about the Inferno tool already. The focus of this talk is actually on the layers underneath that, um, although I think the lessons learned here will apply really to your testing on any level. So when we look at the IBM FHIR server, these are some of the key components. So the model makes up really the base of the server and contains a Java class for each of the different resource types and data types, and as well as the parser and generator for reading and writing these resources, both JSON and XML. Validation sits on top of that and applies schema level validation and secondary constraint validation, as well as terminology binding and terminology value set membership checking. Next, we've got the persistence layer and search, and finally logic. So the IBM FHIR server provides persistence interceptors as well as a way to extend the server with custom logic and extended operations. And I think some of the other open source FHIR servers do similar. When we look at testing each of these components, we use an example-driven approach. So at the FHIR model level, we'll round trip from example files into our object model and back. At the persistence layer, we do similar, but to the database and back, on up the stack. And finally, like at the logic layer, we'll throw a lot of different variations of resources in and look for logic errors in the logic in the tests. So to do this example-driven testing, we need a lot of examples. And so here's some of the core sources for the core specification has examples for each and every resource. And so if you go to one of the pages on the FHIR web page, you'll see a tab for examples, and you can go there to get a feel for what an actual instance of each resource type might look like. Similarly, the Synthia project is really a go-to for the community for generating synthetic patient data. So this will generate realistic patient data according to broad ability to configure it. Each implementation guide will have its own set of examples, and oftentimes if you participate in a FHIR Connectathon, you'll find that the Connectathon track leads have specific examples for specific use cases, as well as sort of maybe a test script or Postman collection or similar. And then finally, we have some IBM-generated examples that we'll cover in a bit. So all of that is packaged in our project into a single jar file with a couple lightweight classes on top to help you with accessing the examples by path or by index. And we look at the IBM-generated examples, that really comes in three flavors. And what we found is that in our DSTU2 server that was used internally at IBM, we had a lot of spot checking in our tests. So as we started tackling new use cases, we'd add examples and tests that are relevant for those use cases. But it didn't always lead to the greatest coverage, and you might find that when you tackle a new use case, you find new issues that you hadn't previously considered. So what we were looking for is a more systematic approach for testing the full breadth of the FHIR specification to avoid surprises as we tackled new things. And the generated examples give us a way of doing that. So here's a hypothetical method, some custom logic that was written to generate a list of patient surnames. So the logic here is basically we'll get a list of patients, perhaps as a result from a search. We'll loop through those. For each patient that's active, we're going to get all the names and print the surnames. And there's a logic error hidden in here that we'll try to find through our generated tests. So first we have our minimal examples. So just like the name says, this is the minimally valid instance. We do include a tag on the resource just so that we know where it came from. But you can see the patient resource has no required fields. All the cardinality has a minimum cardinality of 0. And so a minimal patient actually has no fields, or just a meta field in this case. So when we feed that through our code block, we hit a null pointer. The moral of the story here is that there's a lot of optionality in the FHIR model, and when you get instances that don't have fields that maybe your typical resources would include, it's easy to miss a null check, in a language like Java, or to fail to handle these cases properly when you have missing data or missing fields. So this one's pretty simple to fix. We'll just add a null check. So now we'll only try to use the value of the active field if it's actually not null. So when we look at in resource type like observation, there's actually required fields. So status and code are both required. And so our minimal observation actually requires these fields. These minimal examples, one of the things we use them for is in our unit tests. We used to kind of grab the full test instances and then tweak them as needed, because it can be a pain to create through code the kind of minimally viable, the minimally valid instance. It's easier just to kind of start with a working base. So we would grab, some of the full FHIR examples from the specification, and it led to a lot of kind of duplication of examples throughout our projects, throughout our tests. And so by consolidating all that under the FHIR examples project and then starting from these minimal instances, we're able to just focus on the particular areas of the resource that are under test. The next set of examples we'll cover is the complete mock examples. So the complete mock examples is like the opposite of minimal. So here every single field that's allowed to be present in the resource is present, but with some fake junk data. So this can be really useful for mapping if you want to make sure you're handling all the different fields. It can also be useful for finding errors in the actual specification. An interesting aspect of this is the choice types. So a choice type in FHIR is denoted with this kind of open bracket x close bracket. And so here we have a deceased Boolean or deceased date time, and a given instance can contain one or the other, but not both. And our approach for generating mock examples from these is to generate, we find the element in that resource type that has the greatest number of choices, and we'll generate one per choice for that element. So in this case, we'd have two different patients, one with a deceased Boolean and one with a deceased date time. Contrast that with a required code binding. So the gender here has a required binding to the administrative gender, and that has 4 allowed values. So we could use a similar approach, but in our case, our server doesn't have custom business logic based on the values of these codes, and so we'll just pick one at random. But in your case, you may be interested in tweaking what we have to generate so that you have one instance for each code value. Finally, the third type we'll get into is the complete absent examples. So this is similar to the complete mock, except here there's actually no data. There's all the fields but no data. So when we run this one through our little program from before, and we get back our null pointer. So what's going on here is we have primitive extensions. So in the null pointer previously, the primitive extension was on a Boolean. In this example, we have the name, which is a string type. So in FHIR, it can be a string and have no value, and instead only have extensions. In the JSON representation, that's even more interesting because instead of having a family attribute name, we actually have an underscore family, which has the extensions under it. And in the case of a repeating element like given, we actually have this parallel arrays structure. So the given element has a list of given names. In this case, it's null, and that null corresponds to the first index of the underscore given array. So the fix for this one would be to add another null check, or we can use this pattern of Booleans. So now we'll handle an active value that is either true, false, or null. So that's pretty much all the time we had for today, but we'd love your feedback on our generated examples, on our FHIR examples project, or really anything you want to talk to us about. You can find us on the IBM stream on the chat.phir.org, or contact us through issues on our GitHub repo. I'll stop here for questions. All right. As a little bonus here, if we have time, I wanted to cover the IBM FHIR persistence search tests. So this is another set of generated examples that we have, but in this case, it's really used specifically for search testing. And so what we do is we've organized around the search parameter types, and rather than finding one search parameter type, throughout all the resources in the specification, we took a more basic approach where we use the basic resource to find custom search parameter definitions on extensions. And so it's a more systematic approach for making sure that we're testing every combination that's allowed in terms of mapping data types, like primitive or complex data types in the specification to search parameter types. So that's about all we have time for. Once again, thanks again. Thanks to the sponsors and for everyone for attending. We'd love your feedback, so don't forget to fill out that feedback, and we'll talk again soon. Thanks so much. Bye.